Good morning, students. Today we'll discuss about as the last class of interrupt, that is last or second last class of interrupt, that is only two topic is remaining, that is one of the most important instruction, that is a ream instruction, and after that a special non-maskable interrupt, that is trap, and one interrupt controller programmable peripheral interface 8259A, Intel 8259A. So we will explain those things one by one. First, the ream instruction, it stands for read interrupt mask, and it will load the accumulator with an 8-bit pattern showing the status of each interrupt pin and the mask. So what is actually going on, that is actually shown here in this picture. You know that there are total three type of RSTs are there. Those are considered as a vectored interrupt, that is RST 7.5, 6.5, and 5.5. So those are the corresponding masking bits, and that is actually shown the in case of ream instruction. That is actually the content of the accumulator. So when ream instruction will be applied, then corresponding these masking bits will be copied into the respective these three bits, that is 0th bit, 1th bit, and 2th bit of this accumulator will consist of the masking bit of the respective interrupt, starting with 5.5, then 6.5, then 7.5. Okay. After that, the interrupt enable, that will enable that interrupt enable flip flop. Whatever may be that particular content, that will be placed here, that is IE, that is 3 bit. And after that, the remain these 3 bits, that is the additional 3 bits, are for pending interrupts. Those are not associated with these 3. This is actually associated with pending interrupts. So what is the status of that pending interrupts? That pending interrupt status is also indicated by these respective 3 bits, that is 4, 5, and 6, corresponding pin to RST 5.5, RST 6.5, and RST 7.5. Okay. Now, the last one, that is for serial data input, it is actually connected. This particular bit is connected with the SID pin of the 8085 microprocessor. So that particular pin, that particular thing, whatever may be present on that SID pin of 8085, that particular bit, either it will be a 0 or 1, that will be copied here. So this is all about the 8 bit of the accumulator. When ream instruction will be applied in a program, then corresponding from these different portions, these different bit patterns will be loaded into the accumulator. Okay. So by the ream instruction, actually we will read the status of the current mask bits of the current interrupts, as well as if there is any pending interrupts are there, and if these pending interrupts are there, then what is their conditions, and corresponding if there are any serial input data. So these three type of information we will get into as a bit pattern of the accumulator. Okay. So actually we are reading the status, we are not changing anything. Now, whatever I have already told you, that is actually written here, corresponding these three bits. 0 means available, 1 means masked. Here there is interrupt enable flip flop value. Corresponding, these are the pending interrupts corresponding status, and there is serial input data. Okay. Now, these things is already written here. Then pending interrupts, since the 8085 has total 5 interrupt lines, so and interrupts is actually asynchronous in nature. So when a particular program is already executed by the 8085, any interrupt can happen. In the same way, when an interrupt already is in progress, on that time some another interrupt can also happen. So that's why this when an interrupt already is in progress, on that time if some additional interrupt happen to that 8085, that additional interrupt will be said as a pending interrupt. So that particular status of those pending interrupts is actually status we can get with ream instruction. So that is actually written here. Using the ream instruction, the programmer can read the status of the interrupt lines and find if there is any pending interrupt. The advantage is being able to find about interrupts on RSTs without having to enable low-level interrupts like INTR. we don't have to enable the low-level interrupt INTR, because we know that this INTR have lower priority than all of these. Okay. And now using Veeam and SIEM to set the individual mask. So when a particular one will handle different type of interrupts. So when first we have to get the status of what is the current status of the interrupts. Is there any pending interrupts? What is the masking bits positions? That we have to get using Veeam instruction. After that, we have to, according to our need, we will change the corresponding accumulator content, and after that, that accumulator content will be applied as a change of the status by using SIEM instruction. So there are total three processes. First we will use SIEM instruction, after that we will change the accumulator content, and at the last we will use SIEM instruction according to that particular accumulator content that we have already changed. Okay, so that is actually happening here. This is a ream instruction. That means that is the corresponding status, present status. After that, we are ordering this content by setting the bit 4 for MAC. That is, we are only, everything is unchanged. Only these 0 we are starting to 1. So 1 means we are enabling that interrupt. Okay, that is interrupt enable flip-flop we are enabling, and all the others will be same. And after that we are ending that particular 0DH with the content of the accumulator, that is that one. So why we are doing this, that means we are assuming that RST 5.5 and 7.5 are enabled. So these are the situation, but here that all these things are available, and corresponding all the other bits are don't cares are in 0. So whatever that is already written. So that's why we are ending 0D8 with this particular accumulator content. So that is the new content. And after changing that new content, we are just using SIEM instruction. That means this particular settings will be applied to the system. Okay. So in this way, when Veeam instruction and SIEM instruction, Veeam and SIEM instruction will be used. First, through the Veeam instruction, the corresponding current settings or the current status of the system will be read, and after that, according to our need, the corresponding accumulator content will be changed by different OR and AND operation. Okay, and after that OR and AND operation, when we already got the desired bit patterns. Okay, after that we will apply that bit pattern to that particular system, so that whatever we are asking to do to that particular system according to the interrupt, that is whatever may be the change, what is that whatever may be the change we are going to perform, that particular thing will be applied by using SIEM instruction. Okay, so this is all about RIM and SIEM instruction, and how you will apply this RIM and SIEM instruction to change the corresponding interrupt processing in a particular system. Okay, and after that, the as a last interrupt, that is trap. You know that trap is a non-maskable interrupt, and since it is a non-maskable interrupt, that means it cannot be masked. So that means when trap will happen, on that time the trap will be immediately processed by 8085. It cannot be delayed. So obviously trap will be, if it is a non-maskable, that means the trap will be of highest priority. So that's why trap is a highest priority interrupt, and that's why it is a non-maskable interrupt. It belongs to a vectored interrupt, and it cannot be disabled, and it is age and both age and level sensitive. That's why it cannot be delayed, and since this trap is a highest priority interrupt, that's why very crucial information about the system like power failures or emergency shut off, this kind of very emergency situations can be handled by this trap. Okay, so this is all about the different type of maskable and non-maskable interrupts, as well as vectored and non-vectored interrupts. So if we are thinking from the starting of this interrupt chapter, then we have already learned about different type of interrupts, that is maskable and non-maskable, as well as vectored and non-vectored interrupts. What are the different non-vectored interrupt, and there are total 8 different non-vectored interrupts was there, that is RST0 to RST7. Okay, all these RST0 to RST7 have different interrupt service routine starting address. So how those are generated and how can be handled by 8085 all along, that we have already know. After that, we know about the different vectored interrupts, and that vectored interrupts consist of RST 5.5, 6.5, 7.5 as a maskable interrupt, and trap as a non-maskable interrupt. Okay, and after that we have known about two very important instructions that will mainly use to handling with interrupts, that is the ream instruction and seam instruction. We also understand that what is the different circuits are responsible for working with pending interrupts, as well as different priority interrupts, how priority will be determined. All of this we already understood, and how this ream and seam instruction is already used to perform different interrupts related operation in 8085, that we already know. So this is all about the interrupt chapter. Only one thing is remaining, that is an interrupt controller. So it will take a separate class to discuss. So thank you. So if you have any kind of problem regarding this interrupt chapter, okay, so you are free to contact me. Thank you.